Look at this comet! Recently, it's erupted 4 times in less than 48 hours and has become nearly 300 times brighter than normal. This is the most powerful set of eruptions the comet has had in over 3 years. Should we worry here on Earth? Well, I wouldn't say scientists are worried. They're super excited. First, let me give you a little background. 29P is what astronomers call a centaur comet. Those are icy objects that orbit the Sun in the space between Jupiter and Neptune. What's interesting about centaurs is that they're kind of like cosmic hybrids because they're moving from one kind of space body to another. They start their life as far-out objects in a lifeless, freezing cold zone beyond Neptune. But then, over a few million years, they move inward toward the Sun because the planets of the solar system affect them with their gravity. Eventually, they turn into short-period comets. This term means they can pass close to the Sun and then slingshot back out into those icy regions. Centaurs, and their name indeed comes from a hybrid half-horse, half-human creature popular in Greek mythology, are especially interesting because they're basically leftovers from the formation of our solar system, kind of like cosmic fossils. Since they've been hanging out in the frigid outer solar system for so long, they've kept a lot of the volatile materials that were present when the solar system was first forming. This makes them a valuable clue in understanding how our solar system evolved. That's what makes scientists so enthusiastic. Now, about 29P itself. This thing is huge for a comet. It's about 37 miles across, which is almost 3 times the length of Manhattan. Now, worry not, it's too far away to cause us any harm. While it's one of up to 1,000 known centaurs, 29P is also in a rarer group of comets called cryovolcanic comets. Those are a fascinating class of space objects that have unique geological activity. The thing is, cryovolcanic comets not only contain a unique mix of ice, dust, and rock, but also feature cryovolcanoes, aka cold volcanoes. They erupt with volatile materials like water, ammonia, or methane instead of molten rock. As for regular comets, when they approach the Sun, the heat from the star evaporates their gases, leading to the emissions of dust and tiny particles, electrons, and ions. These materials create those magnificent trails. These eruptions are incredibly spectacular and make the comet appear a lot brighter since the cloud of cryomagma reflects the Sun's light. The cloud that forms around the comet is called the coma, and it can grow so large and bright that it makes the comet look like a fuzzy ball of light. If you've ever observed a comet, the coma is the halo you see around it. Such eruptions are pretty unpredictable. While most cryovolcanic comets follow elliptical orbits that take them far out into the solar system, 29P is on a more circular orbit, staying around the same distance from the Sun as Jupiter. You'd think that this would mean its eruptions would be more regular, but that's not the case at all. In fact, 29P erupts in a completely random and unpredictable way, and scientists are still trying to figure out why. The latest outbursts started on November 2, 2024, when 29P erupted for the first time in almost 2 years. This was followed by 3 more large eruptions in less than 48 hours, which really got the attention of astronomers at the British Astronomical Association. They'd been tracking 29P for a while, and they reported that the eruptions sent out a cloud of debris reflecting about 289 times more light than the comet's nucleus, which is a huge increase in brightness. Astronomers are expecting that the coma, which is growing after each eruption, could take on an unusual shape. The multiple outbursts might cause the coma to expand in a weird, irregular way. This is especially interesting because 29P hasn't had a major eruption like this since November 2022. Then it threw out over 1 million tons of debris. The last time it had a massive outburst was in September 2021, when the comet had multiple eruptions in quick succession. In addition to the confusion about its eruptions, 29P is pretty different from most other comets. Most comets have elliptical orbits that take them far out into the solar system. They spend decades, centuries, or even thousands of years far from the Sun, only to erupt when they get close. But 29P doesn't do that. No, it orbits the Sun once every 15 years and stays at about the same distance as Jupiter. This strange behavior makes astronomers even more eager to figure out what's going on with it. Another cool thing about 29P is that it doesn't ever get close enough to the Sun to grow a tail like other famous comets, such as the once-in-a-century comet, Tsuchinseng Atlas, which has recently made headlines. It passed the closest to Earth in 80,000 years. NASA's James Webb Space Telescope has been keeping an eye on 29P, helping solve some of the mysteries about the comet. And it has recently made another groundbreaking discovery. It has detected jets of CO2, good old carbon dioxide, coming from the comet. This was the first ever detection of CO2 jets on this particular comet. Webb has also discovered a jet of carbon monoxide coming from the comet. It can tell us a lot about the composition of the comet and its outbursts. What's especially interesting is that the jets seem to come from different parts of 29P's nucleus. Even though Webb can't actually figure out the nucleus itself because it's too small to see in detail, the jets coming from different locations on the comet's surface suggest that the nucleus may be made up of multiple objects. These objects might have different compositions, and it's possible that the nucleus is more of a composite body made up of smaller chunks that came together over time. Strangely, astronomers haven't detected any water vapor in the comet's atmosphere. That's unusual because the atmospheres of most comets often contain water. Our comet might lack water vapor due to the extremely cold temperatures on its surface. It could prevent water from evaporating or vaporizing. 29P isn't the only thing that Webb is studying. The telescope has also been making some big discoveries about galaxies far, far away. For example, Webb has recently spotted a galaxy with a pretty complicated name which appeared about 1 billion years after the Big Bang. What's super weird about this galaxy is that the gas in it is shining brighter than the stars, which is really rare. This could be a missing link phase in the evolution of galaxies, something that could help astronomers understand how galaxies transition from the very first stars, called population 3 stars, to the types of galaxies we see today. The stars in this galaxy are much hotter than we see in modern galaxies in local universe, around 144,000 degrees Fahrenheit, compared to the typical 72,000 to 90,000 degree Fahrenheit of stars today. This could mean that the galaxy is in the middle of a super brief but intense phase of star formation, where huge, hot stars are popping up in a dense gas cloud. And this gas cloud is glowing so brightly because it's being hit with tons of light from these stars. The research team behind this discovery says that although the galaxy doesn't have population 3 stars, because the data shows it has too much chemical complexity, it still could be a guide for understanding how galaxies evolved, from the first stars to the galaxies we're familiar with today. There are still so many questions about this galaxy. Is it a rare phase? Or is it something that happens often in the early stages of galaxy formation? Astronomers are hoping to study more galaxies like this one to figure it out.
Picture a silent ember drifting toward the Sun, moving so quickly that no gravity well in our system can bind it. That ember, provisionally tagged 3I Atlas, appeared in late June when the Atlas Hazard Survey cameras in Hawaii and South Africa logged a faint, fast intruder. Initial orbital fits showed an eccentricity greater than 1. The mathematical stamp of an origin beyond the Sun's reach. We have met only 2 such emissaries before, 1I Oumuamua in 2017 and 2I Borisov in 2019. Now a third arrives, tugging at our curiosity and our instruments in equal measure. The object's present speed is almost 70 kilometers per second, enough to span New York to London in 90 seconds. Backtracing the path leads toward the constellation Lyra. Forward projection shows a swing past Mars on 3rd October 2025, a solar perihelion 20 days later at twice Earth's distance, and final escape by early 2026. Earth stays on the Sun's far side throughout, so the risk ledger reads 0. The intrigue ledger, however, is packed. Composition sits at the top of the to-do list. A comet would sprout a gaseous veil as ice evaporates, yet deep imaging has yet to reveal any coma. An asteroid would follow purely gravitational curves, yet a whisper of extra thrust may lurk in the astrometry. The James Webb Space Telescope can cut through reflected sunlight and sample the infrared glow for water, carbon monoxide, or exotic minerals. If the spectrum comes back featureless or metallic, theories multiply. Brightness fuels the puzzle. Even with a modest albedo, the observed flux implies a body several kilometers wide, far larger than Oumuamua, whose size was measured in hundreds of meters. A highly reflective hull could achieve the same luminosity with far less mass, a possibility that keeps technosignature specialists awake. Professor Avi Loeb, already known for suggesting an artificial origin for Oumuamua, is lobbying for continuous JWST tracking to test for non-gravitational acceleration. A persistent drift unaccounted for by gravity would demand explanations that push against the boundaries of conventional astrophysics. Statistics pose the second riddle. For centuries, astronomy recorded 0 interstellar passers-by. Now we count 3 in 8 years. Better sky coverage explains part of the surge, yet simulations indicate the detection rate is still high. Either the density of galactic debris is underestimated, or transient swarms are sweeping the Sun's neighborhood. The Vera C. Rubin Observatory, starting full operations next year, will clarify the odds by mapping every moving speck down to faint magnitudes every few nights. Structure forms the third unknown. Light curve monitoring can reveal whether 3I spins like a platter, a spindle, or a rubble pile loosely bound by microgravity. Oumuamua's flattened shape and unexplained kick remain controversial. A repeat would strengthen calls for new physics or new engineering. Rapid tumbling might indicate past collisions, freshly exposed ice, or even deliberate attitude control. That opportunity extends well beyond the object itself. Each interstellar visitor carries isotopic fingerprints of the chemistry that shaped alien worlds. Sampling those fingerprints, even remotely, refines models of planet formation, volatile delivery, and the migration histories of giant planets. In a decade, robotic missions may be fast enough to intercept such bodies. Today, we practice with photons. Time is tight. By September 2025, the object will vanish into solar glare. By the time it re-emerges, the outbound leg will dim below major telescope thresholds. Roughly 5 months remain for the most ambitious observations. Teams are coordinating radar pings, ultraviolet spectra, and high-cadence photometry to squeeze every bit of information from the fleeting visitor. Why should the broader public care? Because 3I Atlas is a tangible reminder that our solar system is not an island, but a crossroads. Somewhere, an unknown star flung this body into the dark, perhaps through a near miss with a giant planet, perhaps through a cataclysmic collapse of a binary pair. After wandering for millions of years, it has brushed past our doorstep, offering a message in a bottle. The galaxy is bustling, and we are part of that bustle. Whether the newcomer proves to be ice, rock, metal, or something unprecedented, its brief appearance renews a sense of frontier. Sky surveys sharpen, theories adapt, curiosity deepens. The next discovery may come sooner than anyone expects, and when it does, the groundwork laid today will allow us to read its story more clearly. For now, astronomers chase a streak of light across CCD frames, and every clear night might deliver a clue that rewrites chapters on planetary science, or adds a footnote to the search for artifacts among the stars. In either case, the sky is not done surprising us. Origin scenarios abound. Some simulations eject 3I from a nascent planetary system after a close brush with a giant planet, while others invoke a crowded stellar nursery where passing stars fling debris across interstellar lanes. Whatever the trigger, the body has drifted for perhaps tens of millions of years, carrying the isotopic signature of an alien chemistry lab. Radio arrays will also listen for narrow-band emissions, more out of thoroughness than expectation. After Oumuamua, technosignature protocols are standard. Scan, archive, move on, unless a signal repeats. Looking ahead, Rubin's legacy survey of space and time should uncover several interstellar objects every year, identified early enough to permit rapid robotic flybys. Concepts under study at multiple space agencies outline launch-on-alert missions that could sample surface dust or even return grains to Earth. Each discovery thus acts as rehearsal for the day we chase one down in person. Whether the outcome is ordinary or transformative, the chase itself pushes instruments, sharpens global teamwork, and teaches the next generation to aim beyond yesterday's limits.
So hi, How about exploring some cool and unusual artifacts from the past? Let's go! Have you ever heard of Chinese magic mirrors? These mirrors were made of solid bronze. They had two sides. The front was a shiny polished surface, similar to our typical mirrors. It was the back that did the magic. When bright light fell on the mirror, it looked as if it was transparent, and the pattern on the back of the mirror got projected onto the wall. The backside could have different designs on it, depending on what its creator wanted to depict. Since the mirror was made out of bronze, no one expected this optical illusion to occur. These ancient artifacts date back to 2900 to 2000 BCE. They became popular in China and were produced in large numbers at the time. Eventually, their fame faded away. For centuries, the magic of these mirrors baffled both people and scientists. In the 11th century, Chinese scientist Shen Ku decided to study the mirrors. He conveniently had 3 of them. He was surprised by the ability of the metal to act as if it were transparent. He believed that some tempering techniques created surface wrinkles on the mirror to make it translucent. Yet these wrinkles were imperceptible to the human eye. It turns out he was right. Many scientists tried to decipher the open mirrors over the centuries, but remained clueless. Finally, in 1932, William Bragg discovered that Shen Ku had been right about imperceptible surface wrinkles all along. Every once in a while, people open multiple tabs in a browser and come to a point where there's no room for a new tab. Apparently, this had also been happening long before computers and the internet were invented. Meet the 16th century browser. This is a full-size book wheel. It's kind of a custom-made rotating bookshelf. Gregory Hayworth, a specialist in textual science, says that this tool has a system of epicyclic gears. That means that the book wheel has a working principle like a planetary system. One gear rotates around another. The shelves of the device maintain a constant 45-degree incline that holds the book securely as the giant wheel turns. Back then, people used the tool while writing encyclopedias and editions of classical works. In this kind of work, a person has to have many books open simultaneously so that the information from multiple sources can be gathered easily. Italian engineer Agostino Ramelli is the inventor of this piece of early modern machinery. What if I tell you that sponge divers in Greece accidentally found an ancient computer? They pulled out this artifact from a shipwreck near Antikythera Island in 1901. Scientists called it the Antikythera mechanism and labeled it as the first mechanical computer. The machine looks like a hunk of bronze, but it has some kind of mechanism composed of gears and wheels. So, experts first assumed that it was an astronomer's tool. After an X-ray scan, though, they found out that the instrument was far more complex than they thought. The artifact was meant to calculate astronomical positions, track the 4-year cycle of athletic games, and so on. It contained a box with dials on the outside and had an assembly of gear wheels attached. It's still unknown who built an instrument with this level of artistry 2,000 years ago and why this technology was lost. After seeing how sophisticated the device was, scientists accepted that their perception of ancient Greek engineering wasn't really accurate. Professor Michael Edmonds of Cardiff University admits that, based on the knowledge they have, this mechanism shouldn't even exist. Edmonds says the machine is one of a kind, and its astronomical calculations are precise. For him, the Antikythera mechanism is more valuable than the Mona Lisa. In 1929, scholars working in Topkapi Palace Museum in Turkey discovered a map. It became famous for being the oldest map showing the Americas. Perry Rees drew this detailed map on a gazelle skin in 1513. He depicted Europe, North Africa, the coast of Brazil, and several islands, such as the Azores and Canary Islands. The most exciting thing is that he created the map only 21 years after Columbus had set foot in the New World. Well, it was new to him. Perry Rees was a maritime scholar and a successful naval commander leading the Ottoman fleet. Yet, while drawing the map, he relied not only on his expertise in sailing. He created it by assembling and referring to 20 other regional maps, like the Arab map of India, 4 Portuguese maps, and the map of the western parts drawn by Columbus. Yes, the part he got from Columbus raised the heartbeat of many historians. Columbus drew a map during his 3rd voyage to the New World and sent it to Spain in 1498. It's assumed to be lost. Surprisingly, historians can now understand what Columbus noted down by looking at Perry Rees's map. Fun fact, he also drew another world map in 1528. Even though only about 1/6 of this map has survived, it's clear that it described the northwestern part of the Atlantic, the region from Venezuela to Newfoundland, and the southern tip of Greenland. The map also showed Antarctica centuries before its discovery. Historians had to rethink the chronology of history after getting this crazy information. Perry Rees described Antarctica's topography without ice in great detail. In the 1930s, workers found dozens of stone spheres in Costa Rica. Locally, they're known as bolas de piedra, literally stone balls. They were made by a civilization lost in time. What's interesting about these balls is their shape. They are perfectly spherical. How ancient people could make such precise shapes is a mystery. The spheres are of different sizes. Imagine a small one, like a tennis ball. Then put another one next to it, 7 feet in diameter. The largest spheres weighed 16 tons. Archaeologists are sure that these balls are human-made. Yet their purpose remains unclear. Some archaeologists claim that the spheres could represent the solar system or could be inspired by various stages of the sun and the moon. Others say that the stone's placement refers to the houses of chiefs. Most of the stone spheres were sculpted from granodiorite. It's a hard rock similar to granite. Experts believe that ancient people used smaller rocks from the same material as tools to shape these spheres. They also think that sculptors probably heated portions of the stones and then cooled them rapidly. This could have helped them to remove the outer layers of rock. Our next one is an ancient battery set found in Iraq in 1936. The set consists of a ceramic pot, a copper cylinder, and an iron rod. At the top, the iron rod is isolated from the copper by asphalt, and both the rod and cylinder fit inside the mouth of the jar. The copper cylinder isn't watertight, so if the pot was filled with a liquid, it would surround the iron rod as well. Archaeologists focus more on the oxidized iron rod because the vessel just needed to be filled with an acid or alkaline substance to produce an electric charge. After examining this bizarre artifact, an Austrian archaeologist hypothesized that the instrument made use of chemical reactions to generate electrical energy. That's why they likened the instrument to a battery. An ancient civilization might have used it for some kind of electrotherapy. Yet there isn't any electroplated object known from this period. So Koenig's hypothesis was rejected by many archaeologists, but nobody has proven him wrong either. The origin and purpose of the vessel remain unclear to this day. So, want to see the world's oldest art studio? In 2011, archaeologists found 100,000-year-old shells in a South African cave. Those shells were used for paint making. A coating of bright red powder on the inside of a pair of shells is the proof. Archaeologists say they found a complete kit used to produce a pigmented mixture. Now, in a different part of the cave, several paintings were displayed with little price tags on them intended for sale. Nah, just kidding. Although that big one over there would look good over my couch.
There are tons of weird things on Mars. Spoons, noodles, doors, even faces. Are they all really just rocks? Besides, it's not the only planet in our solar system full of mysterious things. Let's check them out. Recently, we found a strange thing on Mars that looks like a smooth, spoon-like object. It grabbed everyone's attention after NASA's Curiosity rover spotted it. The rock, with a handle and rounded tip, looks like it's floating in the rover's photo. People on the internet are puzzled about what it might be. Some are joking that it's a Martian's bowling pin, or even a shoehorn left by extraterrestrial creatures. But Andrew Good from NASA says it's not that exciting. Turns out it's just a rock shaped by the wind over a long time. These kinds of rocks with odd shapes are common on Mars. They're called ventifacts. Ventifact is a rock that can get scratched, dented, or smoothed out by tiny particles carried by the wind. You'll usually find these kinds of rocks in dry places where there's not much grass or trees to block the wind, and where there's a lot of sand blowing around. Sometimes, the wind can carve ventifacts into really cool shapes, like the mushroom rocks you can see in the White Desert National Park in Egypt. These rocks look like giant mushrooms because the wind wears away the bottom part faster than the top, making them stand tall and slim. Ventifacts aren't the only cool Martian rocks. Check out this series of surreal spikes protruding from the red surface. NASA's Curiosity rover stumbled upon them while exploring the Gale crater on Mars. They quickly caught everyone's attention. Twisting structures resembling spikes looked like some extraterrestrial doors. Even the SETI Institute, an organization focused on searching for extraterrestrial life, tweeted about the image, referring to it as a cool rock. But in reality, these are just hoodoos. These tall and thin spires occur when hard rock sits atop softer rock layers. Martian spikes are likely cemented fillings of ancient fractures in sedimentary rock, with softer material eroded away over time. Again, there are many hoodoos on Earth too. They're also called fairy chimneys or tent rocks. You can find them in places like Utah's Bryce Canyon and the Colorado Plateau. NASA is excited about these weird structures because they can help us learn more about the history of the Gale crater. There was also a rock that looked like a jelly donut. We called this rock Pinnacle Island. It was spotted by NASA's cameras. However, just 4 days earlier, it was nowhere to be seen. So how did it magically disappear? In a very anticlimactic way, it was kicked up by one of Opportunity's wheels as it traversed the Martian terrain. But there's still some mystery surrounding that jelly donut. Analysis revealed that Pinnacle Island contains unusually high levels of sulfur and manganese. Both of these things are water-soluble. In other words, there might have been some water action that created these elements in the rock. So this tiny thing suddenly caused a lot of drama, and an entire lawsuit against NASA. It claimed that the agency failed to investigate a possible fungus growing on Mars. Jelly donut fungus. But not all our findings are natural. Another puzzling discovery was this thing the Perseverance rover spotted. It's something that looks like tangled spaghetti or string. Just like the donut, this mysterious object showed up in a rover camera image and then vanished from the sandy ground in several days. It turns out that it could be debris from the rover's landing system. Perseverance landed in the Jezero crater in February 2021. It had a rough landing and accidentally scattered debris around. Some of these debris pieces have been showing up in the rover's images for a while now. The string-like object is likely a piece of shredded Dacron netting, which is a type of fiber used in thermal blankets. These blankets help regulate equipment temperatures during the super hot process of landing on Mars. It probably underwent significant unraveling and shredding due to strong forces during the landing. Thermal blankets lost a bunch of stuff back then. For example, this shiny foil piece spotted in June. The rover found it on a rock. What's remarkable is how far some of the debris has traveled. The rover landed about 1.2 miles away from where it's currently exploring. It's probably because the crash threw the debris into the air, and the Martian winds carried it over such a distance. Mars is known for its strong winds, which can move lightweight objects. However, while it's fun to stumble upon them on images, there are concerns about the debris and trash on Mars. We haven't even fixed this problem on Earth, and we're already creating it on Mars. The debris we left on the red planet is already accumulating in an area called Hogwallow Flats. Plus, the debris can accidentally contaminate the sample tubes used for collecting Martian rocks. So far, NASA isn't overly worried about this, but they're keeping a close eye on it to prevent any issues with the rovers. Now, how about not things, but animals? Curiosity caused quite a stir when it captured something that looked like a rat on Mars. Some started speculating that it could be evidence of indigenous Martian life, or even that this rodent was brought along by Curiosity. But the Mars rat, once again, turned out to be just a weird rock. It looked interesting because of the natural processes like wind erosion and mechanical abrasion. We also found some worm-looking things. Curiosity snapped a picture of a formation that looks like worms wriggling across the Martian landscape. Despite its tiny size, this formation stands out with its unique shape and rough texture. It's probably made of durable material resistant to Mars's harsh erosion. And finally, our top mysterious finding is the face on Mars. Cydonia is a region on Mars that has captured both scientific and popular interest. It's located in Mars's northern hemisphere. It lies between heavily cratered regions to the south and relatively smooth plains to the north. There's a theory that the northern plains may have once been ocean beds. Maybe Cydonia was once a coastal zone. This place is full of interesting and beautiful features that tell us a lot about the history of the red planet. But its most interesting feature was the Martian face. This thing gained widespread attention when it was snapped by the Viking 1 orbiter in 1976. Some believed that it was evidence of a long-lost Martian civilization. At first, NASA dismissed it as a trick of light and shadow. But after some analysis, it turned out to be, yep, another rock. We also saw a face of a bear. It was captured by the high-resolution imaging experiment camera. In an image, we can see a circular fracture pattern that looks like a bear's head, with two craters forming the eyes and a V-shaped collapse structure like the nose. The head likely formed because something heavy settled on top of an old hole in the ground. This hole was filled with either lava or mud. The nose-like feature is speculated to be a volcanic or mud vent. But why do we keep seeing these strange things on Mars? Sometimes our brains can trick us into seeing things like faces or objects in rocks and other things. But these are just illusions called pareidolia. Pareidolia is a psychological phenomenon that makes us see familiar patterns or shapes, especially faces, where none actually exist. It's because the brain encounters something it doesn't recognize or understand right away. It tries to find things that look the most like this one. So it sees random patterns, textures, or sounds as something meaningful and recognizable. That's why a chair and clothes on it seems like a super creepy human-like figure at night. It also causes you to see faces or shapes in clouds, or hear recognizable sounds and even words in random noise. It's a fascinating proof of the power of our perception, but we also should be careful with it and not let our imagination run wild. Around 66 million years ago, dinosaurs disappeared from the Earth, except for the ones that eventually turned into birds. Suddenly, the Earth went from the age of dinosaurs to the age of mammals. Scientists have special names for these time periods: the Cretaceous and Paleogene. And the event itself is called the KPG, or KT extinction. Picture this dramatic moment in Earth's history. It happened in the blink of an eye. A colossal asteroid as big as Mount Everest and traveling at lightning speed slammed into Earth. It crashed down in what we now call southern Mexico, at a place known as the Chicxulub crater. The impact was gigantic. Everything close to it was instantly vaporized, creating an enormous burst of energy, one of the most powerful in billions of years. Nothing could survive near the crash site. As the fiery aftermath cooled, the Earth's surface went haywire. The ground twisted and trembled, causing unbelievable earthquakes. The continent started to literally bounce. Then, the ocean floor got all stirred up, provoking the gigantic tsunami. Massive waves surged inland around the Gulf of Mexico. The debris that got blasted into the sky started falling back to Earth like a rainstorm. Even if you weren't close to the huge pieces falling in Mexico, you'd still get hit by smaller, super hot bits flying through the air. This heated up the atmosphere so much that forests all over the world burst into flames. The dinosaurs that lived far away from the impact area first felt a little rumble. Suddenly, the sky turned dark and gloomy, as if it was nighttime during the day. The temperatures dropped drastically, and this night during the day lasted for several weeks. And then, a blanket of ash started slowly covering the entire planet. Nasty things like carbon dioxide and bits of the seafloor started floating around in the air. This messed with the temperatures once again, making it swing wildly. The Earth was hot and cold at the same time. Nature was suffering. Forest fires, no sunlight, dangerous gases in the atmosphere. All this caused big problems for plant-eating dinosaurs. They started to vanish, and the meat-eaters were having a feast. But not for long. Soon enough, the whole food chain fell apart. This is when somewhere between 50 and 80% of dinosaurs said their final goodbyes. What's even sadder is that this number only counts the different types of dinosaurs. If we look at the number of individual dinosaur lives lost, it's even higher. Here's an interesting fact. If the asteroid had hit just 30 seconds earlier or later, landing in the Atlantic or Pacific rather than just off the coast of Mexico, we might have had some non-avian dinosaurs still around today. But the way it happened, the asteroid struck with a force equal to 10 billion Hiroshimas. But the only ones who made it were our mammalian ancestors. They were little shrew-like creatures who had super fast energy systems, adaptable diets, or clever hiding spots. These early mammals survived because they were tiny and didn't need much food. We're incredibly lucky that they survived this chaos. They probably didn't even understand what was happening. They just noticed the horrible smell, huge bodies everywhere, acid rain, and volcanoes erupting. So now that we know how terrible this event actually was, let's talk about a big question. Could we, modern humans, survive something like this? Well, it depends. Research from a different asteroid impact about 790,000 years ago suggests we could, but it wouldn't be easy. In that other event, a massive asteroid hit Earth once again. Just like with the Chicxulub asteroid, it sent debris into the atmosphere that covered a tenth of the planet's surface. Scientists found the pieces of that asteroid's impact, glassy rocks called tektites. They analyzed these rocks and discovered a rare mineral called rhyodite. It requires extremely high pressure and temperatures to form. After studying it, scientists assumed that the impact happened in Southeast Asia, probably near Thailand. Strangely, they still haven't found the exact crater. But the main thing is, the asteroid collision did happen, and our ancestors were around during this. It surely got their attention, even though they might not have fully grasped what was happening. The debris from this event would have caused significant climate changes. It's tough to understand how it affected our humans' evolution. All that we know is that we survived it. Currently, there are about 1,200 asteroids on a list of potential asteroid threats, but luckily we're not in immediate danger. These asteroids are smaller than 0.6 miles in diameter. The chance of a massive asteroid like the one that hit Chicxulub between 3 to 9 miles wide striking Earth is incredibly low. Major events like this happen about once every 100 to 200 million years. On top of that, most asteroids are located between Mars and Jupiter and don't pose a threat to Earth. However, there are thousands of smaller asteroids that could potentially hit us. Most of these are small and burn up in the atmosphere, causing no harm. Some larger ones could damage buildings or cities, but wouldn't threaten all life on our blue planet. But what if a comet or a serious asteroid were to collide with Earth today? In that case, first of all, it could alter Earth's orbit. The initial energy released during an impact would cause a scorching blast wave of 570 degrees Fahrenheit. The fire would ignite vast areas of the Earth's surface. Then, it would cause a long-term impact on winter. The smoke from the megafires, along with dust and water vapor, would form a thick layer of clouds in the upper atmosphere. Just like with the dinosaur event, it would reduce sunlight and cause temperatures to drop for decades. Most plant life would die off within weeks. Large trees might survive for decades due to stored sugars and a slow metabolism. Beyond that, not much life would remain, except for microbes and smaller creatures. There are 3 possible strategies for humans to deal with all this mess. The best strategy is to prevent the impact in the first place. Scientists are already searching for asteroids that might cross Earth's path and discussing how to defend against them. One option is to use our biggest weapons to break up the asteroid into smaller pieces. These tiny pieces could miss Earth or burn up in our atmosphere. That would work for asteroids around 0.6 miles wide. However, this won't work for massive Chicxulub-sized asteroids. The amount of energy we'd need to destroy them exceeds our entire current arsenal. But if we notice the asteroid early enough, maybe a series of blasts could change its course and save the day. And, according to the researchers, asteroids larger than 25 miles in size would be nearly impossible to stop with our current technology. Luckily, the chances of something like this hitting Earth are very tiny. But okay, what if we can't prevent the impact? Here comes the second strategy. We'd have to go deep underground and create large bunkers. We know that many burrowing or deep-sea species survived the mass extinction 66 million years ago, so these underground habitants could protect us from the direct impact effects like blasts and fires, as well as an impact winter. We'd have to harness the Earth's natural heat and live inside protective domes. They could be built in stable continental cores or deep beneath the oceans. We'd have some essential supplies like food, medicine, fuel, and water. Maybe even have some gene banks to preserve species. And the last strategy would be to copy the movie Don't Look Up and to ignore the problem until it's too late. We know that it would take collaboration among governments and institutions from many countries to design, build, and launch a series of devices into space in order to prevent the impact. If humanity will be able to pull that cooperation off, that would be a miracle. In any case, NASA takes the threat of asteroids pretty seriously. It has a well-thought-out plan involving early detection, assessment, deflection strategies, collaboration, public communication, and backup plans to protect Earth from these cosmic dangers. So we can only hope that if something like that happens, logic would prevail.
Attention! Attention! Residents of all countries and cities of the world, a massive asteroid is approaching the Earth. Now its speed is several times greater than the speed of sound, and each day it accelerates even more. Once it enters our solar system, it will fly past Uranus, Saturn, Jupiter, and Mars. The gravitational fields of these planets will also accelerate the asteroid, and our planet will be the final destination. A collision is inevitable. According to scientists, a meteorite the size of Mount Everest can destroy the entire planet. The disaster will happen in 350 days. There's panic in the streets. People buy and build bunkers. Scientists and astronomers from all over the world were assembled to find a solution. The only way to avoid the collision is to destroy the space object. Yeah, a powerful rocket can split an asteroid into hundreds of thousands of pieces. In this case, a meteor shower will hit the Earth, but it's better than the complete destruction of our home. In less than a year, people build several powerful rockets. Then, using the best telescopes in the world, astronomers create a unique guidance system. And now, we just have to wait for the asteroid to get into our solar system. All the people start moving to one continent with top-notch bunkers for everyone. The damage from the asteroid is impossible to predict, so it's better to hide people in one super large safe place to wait out the collision. The moment has come. The asteroid passes by Uranus. The speed increases. Now the colossal space object moves only 10 times slower than the speed of light. Scientists launch rockets into the air. The asteroid flies past Saturn and destroys a part of its ring. The asteroid's trajectory is changing. It flies past other planets through a twisting path, picks up speed, and now heads towards the Earth. The rockets leave a long trail of fire behind and reach the speed of sound. They're getting closer to the asteroid. Near Mars, a collision happens. The rockets hit the target. The asteroid explodes and splits into millions of particles. All the pieces fly in different directions. The Earth is saved. At this moment, the Earth's satellites record a huge burst of energy. A small part of the asteroid is headed towards Earth. It's tiny, about the size of a grain of sand. But the explosion accelerated it, and now the grain of sand is flying towards the Earth at a speed of 185,000 miles per second, which is 99% of the speed of light. At this speed, the grain has almost the same destructive power that the entire asteroid had. It's approaching the moon. A few more seconds, and the grain of sand will hit our planet. All the people are waiting with bated breath. The grain gets such incredible power because of the laws of physics. The greater the speed any object is, the more mass and energy it has. When the grain of sand reaches a speed close to the speed of light, its energy and mass begin to increase dramatically. You can't even see this tiny grain of sand, but inside, it has the mass of an entire continent. If the grain reaches the speed of light, its mass will be infinite, and then a black hole will appear. In this case, all living and even inanimate things on the planet will disappear. Trees, seas, and oceans, all the cities, countries, and continents, air, sound, atmosphere, any molecule of the Earth, everything will be absorbed by the incredible gravitational force of the black hole. Then, when there is no trace of our planet, the hole will take over the moon. The gravitational force will grow and absorb other planets of the solar system. Soon, it will reach the sun. Our star will split into thousands of strips like spaghetti and will emit a tremendous amount of energy. This could trigger the birth of a second black hole, but fortunately, we only have 99% of the speed of light, which changes everything. Also, no object that has mass can reach the speed of light. The grain of sand enters the Earth's atmosphere. From the outside, it looks like a blinding meteor that pierces the sky. The grain heats up, passing through the layers of the atmosphere. Clouds within a radius of 100 miles around are burning up. The sky becomes crystal clear. If you look at it in slow motion, you can see the air is ionized because the air molecules are split. In nature, this process occurs during lightning flashes. Our sun also has ionizing energy and disinfects the air. The meteorite leaves an ozone hole behind it. So now, this place is not protected from space radiation and ultraviolet light. The grain of sand flies straight into the center of the Southern Ocean. The closest continent to the explosion is Antarctica. The air around it warms up and mixes with the cold temperature of the ocean, creating hurricanes. As soon as the grain approaches the ocean surface, the water starts boiling. The temperature and energy of the grain are so huge that the water evaporates, but the vapor molecules are instantly burned up. Thousands of gallons of water just disappeared from the face of the Earth. The grain flies down for the first few feet without touching the surface as the water evaporates before it. Then it falls into the ocean and creates a powerful explosion. Hundreds of millions of gallons of water foam and boil because of the hot temperature. The entire ocean within a radius of 100 miles is illuminated with a bright light. The ocean depths, where sunbeams have never been before, are almost as transparent as the water at the bottom of a pool. The wreckage of old sunken ships splits into atoms because of the powerful explosion. Unknown sea monsters and giant squids that live in the dark are afraid of the bright light and swim away. Then, finally, A grain of sand touches the seafloor and penetrates deep into the Earth's crust. If it reaches the Earth's core, the planet will most likely explode from a burst of incredible energy. Fortunately, this is not going to happen. The resistance of the ocean and the ground slows down the grain and takes its energy away. It provokes a slight shift of tectonic plates, and there's more to come. Huge waves form and spread throughout the ocean. The blast wave creates enormous tsunamis. Imagine throwing a small rock into a puddle. The same thing happens to the ocean. Huge waves are approaching the coastal cities. Fortunately, people were evacuated from there, but the damage caused by one grain of sand will cost hundreds of trillions of dollars. Houses are destroyed, roads are flooded. After a while, it starts raining with hurricanes. Ocean water vaporized by the grain forms into huge storm clouds. The wind drives them to the continents. And then, after the tsunami, prolonged rain begins, flooding entire countries. Several days later, natural disasters are still here. The temperature of the Southern Ocean has increased by several degrees. The water is boiling at the collision site, melting the Antarctica glaciers. Millions of icebergs are melting away, so the water level of the world's oceans is rising. The edges of some continents go underwater forever. Thunderclouds reach the Sahara and other deserts. The shift of tectonic plates causes earthquakes on some continents. Volcanoes are awakening. The sky is filled with volcanic ash. It will take months for all the ashes to settle. In the beginning, it creates challenging conditions for life on Earth. Plants and all living things don't receive enough sunlight. In trees and seaweed, photosynthesis is disrupted. Oxygen production stops. It's getting harder to breathe. The air that has filled the planet's atmosphere is slowly running out. People have to adapt to new conditions. They build new cities both on the land and in the ocean. They create plantations with artificial lighting for photosynthesis production. Fortunately, all the problems end when the ash settles. Inside the volcanoes, there's hot magma flowing. It may come in handy as it's rich in chemical elements and minerals. Together with the ash, nutrients fall to the ground, and the soil is now well fertilized. Plants, trees, fruits, and vegetables grow incredibly fast and produce a lot of new oxygen. The Sahara is filled with blooming flowers now, and it looks more like a meadow with flowers, not a desert. The grain of sand just renewed the planet instead of destroying it.